Section 6.2, Parallelograms. A parallelogram is a quadrilateral. A quadrilateral means that there are four sides, with both pairs of opposite sides parallel. So for this to be a parallelogram, those two sides are parallel, and these two sides are parallel. That is a parallelogram. First theorem in the chapter. Opposite sides of a parallelogram are congruent. This is a fact. Every parallelogram, the opposite sides are the same length. We can show that by putting the same number of dashes on each side. Next theorem. Opposite angles of a parallelogram are congruent. So this angle and this angle have to be the same. This angle and this angle have to be the same. Same number of arcs means congruent. Next theorem. Consecutive angles in a parallelogram are supplementary. Let me name some of these angles. So angles 1 and 4 are supplementary. Angles 1 and 2 are supplementary. Angles 2 and 3 are supplementary. Angles 3 and 4 are supplementary. Consecutive angles, which means one angle after the next, and a parallelogram are always supplementary. Supplementary means when you add their measures, you get 180 degrees. Next theorem. If a parallelogram has one right angle, then it has four right angles. So if we put a 90 degrees in here, as we've already learned, the opposite angle has to be the same. So those are both 90. And we just learned from theorem 6.3 that consecutive angles, like these two, are supplementary. If one's 90, what do you add to 90 to get 180? Well, it has to be 90. So if there's one right angle in a parallelogram, they're all right angles. This next one's mucho important. The diagonals of a parallelogram bisect each other. If I draw both diagonals, like so, they will go through each other's midpoints. So this segment and this segment are the same. This segment and this segment are the same. This here is the midpoint of both of those diagonals. Theorem 6.6. Each diagonal of a parallelogram separates the parallelogram into two congruent triangles. Let me just draw one of these, like so. Some facts that we know. Well, we know opposite sides are always the same length. We know the diagonal is congruent to itself. Has to be that from the reflexive property. So if I name these vertices, we know that from this theorem, then that triangle cat is congruent to triangle talk. How do we know that? From the side, side, side congruence that we learned in a previous chapter. Three sides of one triangle congruent to three sides of another, so the triangles must be congruent. Notice I went from the corner of one dash and three dashes in both of these when I named them. So it started at C and it started at T. Then I went across the one dash. I went across the one dash to get to A and O. And then I finished up at the last letter, which was T for the first triangle and C for the second. The same could be said if we drew the other diagonal in the triangle. We could make a congruent statement. So, question 1. Is this a parallelogram? Well, to be a parallelogram, both pairs of opposite sides have to be parallel. And the picture currently shows that this side and this side are parallel because it has those little arrows on them. But the question is, are these parallel to each other? And the answer is yes. The reason we know that, if we got two parallel lines in a transversal, the converse, so we're going to say yes first of all. Then why? The converse to the consecutive angles theorem, consecutive interior angles theorem, I should say, makes I'm going to give these names lines L and N. It makes them parallel. The converse to the consecutive interior angles theorem says if a pair of consecutive interior angles are supplementary, then that makes the lines parallel. So that's what I'm using here. So then, by definition, because both pairs of opposite sides are parallel, this is a parallelogram. Sometimes I try to write fast, and as a result, I have to go back and erase, which makes me go slow. Number 2. Same directions. Is this a parallelogram? If so, why? Well, check this out. Let me name some of these things. Let's call this L. I'm going to extend this. We know lots of things about lines and transversals. So whenever I have a chance to extend lines, I'm going to do so. I'm going to call this line Q. And I'll call this one up here line P. Extending existing lines is called auxiliary lines, even if they're in fact not lines. So check this out. Since 50 and 50 are congruent, that makes these two lines parallel because of the converse to the corresponding angles postulate. Likewise, this other 50 and this 50 are congruent, which makes these two lines parallel because of the converse to the corresponding angles postulate. So we're supposed to say, is it? We're going to say yes, then we're supposed to say why. The converse to the corresponding angles postulate makes L parallel to M and P parallel to Q. Thus, this 3 dots means in conclusion. This is a parallelogram by definition. By definition means by definition of a parallelogram. All right, moving forward. If each quadrilateral is a parallelogram, find the value of x, y, and z. So it's telling us this is a parallelogram. That means opposite sides are parallel. We can put that into our picture. Well, some of these don't require any work. For example, 80 degrees and y, those are opposite angles in a parallelogram. They have to be congruent. Therefore, y is 80 with no work. Angle x and its opposite angle have to be the same. We don't know what those are, but we do know that x plus 80, those are consecutive angles in a parallelogram. They have to be supplementary. Therefore, x is 100. If we extend, make auxiliary lines here, those 3 purple lines, we have 2 parallel lines and a transversal. Y and z are corresponding angles. Since our lines are parallel, that means those are congruent. That's the corresponding angles postulate. Therefore, z is also 80. Moving forward. Number 4. Once again, the direction said these are parallelograms. So I'm going to mark my picture as being so. X is easy because x and 70 are opposite angles. They're going to be congruent. Mark at my picture, write down my answer. If I look at these parallel lines, scratch that, these parallel lines, and this transversal, z and 15 are alternate interior angles. According to the alternate interior angle theorem, those have to be the same, so z has to be 15 degrees. To finish up, looking at this triangle, we already have that x is 70. Once you find angles, put it into your picture. It's going to help you find other angles. Looking at that triangle, the angle Sum theorem says that if you add up all the angles in a triangle, you're going to get 180 degrees. So if I add 70 and 15 together, I'm going to get 85, which means that y has to be 95 degrees. So that answers x, y, and z, so we are finished with that problem. Two more. With the given information, answer each question. Number 5 says, given parallelogram PQRS. I need to draw that before I continue. The order matters. It says PQR to S. So when I draw this, I want to make sure the opposite sides are parallel. Doesn't matter where you start with P, then you have to go around this either clockwise or counterclockwise with the letters. P, Q, R, S. It says the measure of angle P is 2y. Measure of angle Q is 4y plus 30. Find the measure of angles R and S. Well, the opposite angles in a parallelogram are the same. So that means that P and R are congruent, and that means that Q and S are congruent. We also know that consecutive angles, that's step 1, drawing the picture. Step 2 is going to be making an equation from one of the theorems, and one of the theorems said that consecutive angles have to be supplementary. So the measure of angle P plus the measure of angle Q has to be 180. P is 2y. Measure of angle Q is 4y plus 30. If we combine like terms, we get 6y plus 30 is 180. If we subtract 30 from both sides and divide by 6, we're going to get that y is 25. Now the question doesn't ask for y. It asks for the measure of angles R and S. I'm always suggesting that you box in the actual question. Well, the measure of angle R is the same as P, which is 2y. That's 2 times 25. The measure of angle R is 50 degrees. Measure of angle S is 4y plus 30. Y is 25. So we get 100 plus 30, which is 130, and that makes sense because 130 and 50 makes 180 because they're supplementary. When you got this many steps to a problem, number them so that you and anyone else that reads this knows the order in which you did things. One more. If NCTM is a parallelogram, so let me draw this parallelogram. Doesn't have to be perfect because you're going to mark that it's a parallelogram. Pictures are not drawn to scale. NCTM. Doesn't matter where you start labeling it, you just have to go around clockwise or counterclockwise. N is 12x plus 10y plus 5. C is 9x. T is 6x plus 15y. Find the measure of angle M. Opposite angles in a parallelogram are congruent. Consecutive angles in a parallelogram are supplementary. So there's several different equations that I could write from this. Step 1 is drawing the picture. Step 2, I'm going to make an equation. I'm going to add measure of angle N plus the measure of angle C together. They're consecutive, so they're supplementary. So that's 12x plus 10y plus 5 plus 9x equals 180. If I combine like terms, I'm going to get 21x plus 10y plus 5 equals 180. try to simplify this a little bit and subtract 5 from both sides. I get 21x plus 10y equals 175. And I'm not happy about that equation because I can't do anything with it. There's two variables. So I'm going to stop with this for now and see if I can make another equation. So I could set measure of angle C plus the measure of angle T together. That equals 180. So 9x plus 6x plus 15y. That's going to be 15x plus 15y equals 180. Now I recognize I can divide each of those terms by 15 to get smaller numbers. Not something you have to do, but it's something I'm choosing to do. That ends up being x plus y equals 12. So that's step 3. I'm going to take those two equations, put them together down here. I have a system of equations. Each one has two variables, so I should be able to solve this. Step 1, get one of the variables by itself in one of the equations. I chose to get y by itself here and get y equals x minus 12. Take another equation and replace the x in it, pardon me, the y in it, with an x minus 12. If we simplify this, we're going to get 21x plus 10x minus 120. Remember, you're distributing the 10 to both terms inside of there. Combine like terms, 21 and 10. I think I made a mistake someplace. Hold on a second. I did. I apologize. This should be 12 minus x, not x minus 12. I'm sorry. Forgive me, young one. Now if we combine like terms, we're going to get 11x plus 120 equals 175. If we subtract 120 from both sides, we get 11x equals 55. If we divide it by 11, we get x is 5. Once we know that is 5, we can plug a 5 into the other equation for x. And we get y is 7. So the solution to this is the ordered pair 5, 7. Thank you very much for paying attention. That last problem is a bit of a hot mess. I should continue to number these steps. Let's do that. Did that fourth, came over here, then I came over here. So there you go. Please do the homework for 6.2 and have a great day.